Hello, algebra class. I just wanted to give you a bit of an overview of the quadratic forms we've been working with, and it might help with some of the lessons that you're working on. So first off is standard form. We've been working a lot with standard form. It's this one right here. So an example of standard form might look like y equals 2x squared minus 4x minus 16. And in this example here, I've got my a value is 2, my b value is -4, and my c value is -16. So the values carry the sign that is in front of them in each case. Some of the benefits of standard form is that we can see that this is a nice happy parabola. We focus on the a value, and because it's positive, I know that this parabola will be oriented like a smiley face. Because it's greater than 1, it's going to be kind of stretched and a little more narrow than usual. The second thing that we can find easily is the y-intercept. The y-intercept is always going to have a value of x that is 0, because anywhere on the y-axis the value of x is 0. So if we substitute 0 in for each of these x's, we have y equals, well, 2 times 0 squared is just 0, and so this term drops out. -4 times 0 is just 0, and then we have -16 left. And so you don't have to write this out each time, just recognizing that we've got 0, 0, -16. So the c value is always going to be the y-intercept. So the y-intercept will always be in this format, 0c. Okay, moving on to factored form. Well, we could take this format and factor it. That's something that we've learned already. So the first thing we would want to do is look for the common factor, the GCF. I look at the 2 and the -4 and the -16, and is there a number in common? Yes, the 2. I also want to look at the variables. Is there a variable in every single term? Nope, this one doesn't have it. So just we're factoring out 2. So we start in by doing that, we end up with 2 times x squared minus 2x minus 8. Okay, so we divided this by 2 and got 1. We divided this by 2 and got -2. We divided the -16 by 2 and we've got our -8. Then we can go one step further and factor what's left. So we end up with y. Let me back up a second here. I'm going to put my final format over here. So I know that the a value is still 2. And then when I factor this piece, remember we can use a little X or diamond problem to help out with that. 1 times -8 in the top, -2 down here. So what multiplies together to make -8 and adds together to make a -2? Well, let's see, 1 times 8, nah. 2 times 4, okay, I think I can work with that because those are 2 apart from each other. And if I make the 4 negative, that will add together to make that -2, so that works out. Because the leading coefficient here is 1, I can just use a shortcut and go straight to my factored form here. Plus 2 and minus 4. So my factored form is x plus 2 and x minus 4. So this equation is exactly the same as this equation, but this is our factored form. So in this format, my benefit here is that using the zero product property, I know my two x-intercepts. So y-intercept is good in standard form. In factored form, it's good, it's good to find the x-intercept. So to find my x-intercept, I know that my y equals 0. So if y equals 0, we can apply the zero product property, knowing that if this times this is, or if this is equal to 0, either this one or both have to equal 0. So I end up with using that zero product property, I say x plus 2 could equal 0, x minus 4 could also equal 0, therefore x could be negative 2 from the first one. When solved, x could also be positive 4 from solving that one. So my x-intercepts on that parabola can be found, and I could make a little sketch of that. I know that it's smiley, and I know that one x-intercept is at negative 2 and the other one is at positive 4, and it's smiley. So that gives me even more of an idea of what that parabola is looking at. Now the last form we haven't learned how to convert yet. That's one of the future lessons, but the factored form of this same equation would look like this: y equals 2 times x minus 1 squared minus 18. And this is just the exact same equation in yet another format. And this format is really awesome because, and this is what you're going to focus on in this lesson, is that it's called vertex form because the numbers that are right here in the equation help you find the vertex. Whatever h is, notice h is in the same position as this 1. Whatever h is going to give you the x value of your vertex. Notice this says minus, so it's like there's parentheses here, and so the h or x value of your vertex is 1. And then whatever k is, this one keeps the sign, so the k is going to be negative 18. So now I know my vertex is at 1, negative 18. So let's take a look at that and prove that to ourselves on a Desmos. So I'm going to click over to a Desmos screen, and let me adjust this a little bit so you can see all of it. Well, actually that's good enough. Okay, so if I turn on this first equation, graphs it right there. There it is. It's exactly what we expected. The y-intercept is right there at 0, negative 16, as we discussed, and it is kind of narrow and long, and it's opening up. Notice that the a value in every single one of these is 2. That will happen in every format and every parabola. The a value is always exactly the same. All of these other numbers are different though, aren't they? They tell us different things. Okay, so now I'm going to turn on the next one, and this one is blue. It's in the exact same spot. It's different format, same equation. So now let's compare. I mentioned that this format, the factored form, will give us our x-intercept. So our x-intercepts can be found here at 4, 0, which we can see from right here, and at negative 2, 0, which we can see from this factor. Very cool. Okay, and then our last format is graphed in green. And is it in the exact same spot? Oh, yep, it is. It sure is. I just turned that one on and it's in the exact same spot. The vertex of that one, right down there, that value, 1, negative 18. We can see that right here. Positive 1 and negative 18. So this works. Okay, so as part of your lesson, I gave you this to play with. This Desmos. Let me see if I can make this screen open up. Oh, there we go. That's better. So you can see the stuff over on the side. Okay, so with this is something for you to investigate. I've got sliders, so we can change the value of A and H and K. So if I investigate that slider for H, you can compare with the original and see what's happening. Okay, I'm going to pause it at a certain spot. Let's wait until it gets over into positive land. Okay, pause. All right, where is the vertex when we're on H? Okay, it's right there at 2, 0. So notice the value of H. When the value of H is 2, the vertex is at 2, 0. So if we were to substitute that into our equation, it would say x minus 2 right there. And you could see the vertex is right there at 2. Now what if I wanted to also adjust my k value, the value at the end? I can, if I wanted to make that say negative 4, it's going to move that parabola down to negative 4. So now my h is 2 and my k is 4. And look at the value of the vertex, 2, 4. Okay, I'm going to set these back at 1, and we could take a look real quick at what, at 0 actually. We take a look real quick at what the value of a does. Mentioned before that if the value of a is positive, then the parabola is opening up and like a happy face. So if I drag this over here to negative, notice as the numbers get really small, the parabola gets kind of closer to the axis. And then when I get to exactly 0, it goes perfectly flat. It actually becomes a flat line. And then if I go into negative numbers, it makes that parabola flip upside down. Okay, so I encourage you to play with that value. Notice as the numbers get, as it goes farther on that number line, it gets skinnier. It's called being stretched. It's being stretched away from the x-axis. And now I'm compressing it towards the x-axis, and then I get to 0 and it's flat, and then I go back up to positive, and as the numbers get larger, it stretches, 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 taller, 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 and that's how the value of a works in a parabola. Okay, so I encourage you to play with the one that I posted. It's interactive. You can actually press the play button and it will scroll through for you. And then same thing with your H and your K. You can press play and pause and play with those. All right, happy learning. Bye.